Okay, I'm going to do my API 571 study questions with some flashcards from Quizlet. Number one, blank is a change in that microstructure of certain carbon steels and half moly steels after long-term operation in the 800 to 1100 F range. I believe that is graphitization, A. Yeah, and that's correct, graphitization. What structure is 304 stainless steel? I want to say austenitic, B. Yes, 304 stainless steel is austenitic, B. Blank is the result of cyclic stress caused by variations in temperature. Let's see here. Thermal fatigue, B. Okay. General or localized corrosion of carbon steels and other metals caused by dissolved salts, gases, organic compounds, or microbiological activities is called, see here. I believe that is cooling water corrosion. C, cooling water corrosion. What structure is 410 stainless steel? I want to say martensitic, or however you say that, A, martensitic. Yep. The sudden rapid fracture under stress, residual or applied, where the material exhibits little or no evidence of ductility or plastic deformation, is called brittle fracture. It doesn't stretch at all, it just breaks. What structure is 409 stainless steel? I want to say ferritic. Is it ferritic? Yeah, D, ferritic. Low alloy steel contains a maximum of how much chrome? Low alloy steel contains a maximum of, I want to say 9%. D, 9% chrome. Which of the following can be affected by 885 Fahrenheit embrittlement? 410, 430, 308, alloy 2205. I want to say it's obviously going to be E, 410, 430, and alloy 2205. E. For 5 chrome, half moly, what is the threshold temperature for creep? I want to say 800, but I may be wrong. Yeah, B, 800 Fahrenheit. What has been a major problem on coke drum shells? Let's see here. Thermal fatigue. Thermal fatigue is a major problem on coke drum shells. 12. Thermal fatigue cracks propagate to the stress and usually dagger-shaped, transgranular, and oxide filled. Propagate transverse. C, transverse. 13. Inspection for wet H2S damage generally focuses on, it's going to be E, wet seams and nozzles. And that's A and B. See, weld seams and nozzles. What did I say? Wet seams. Blank is a form of erosion caused by the formation and instantaneous collapse of innumerable tiny vapor bubbles. That would be cavitation. B, cavitation. With CUI, corrosion rates with increasing metal temperatures up to the point where the water evaporates quickly. Okay, you're going to increase with increasing metal temperatures, your CUI. Which of the following metals is the most anodic? Be zinc. Most things are zinc plated, so you lose your zinc instead of your metal. Okay. 17. Cracking of dissimilar weld metals occurs on the side of a weld, an austenitic and ferritic material operating at high temperatures. I think It occurs on the ferritic side, if I remember right. Yep. Soil to interface areas are usually more susceptible to corrosion than the rest of the structure because of bacteria and oxygen. Would that be D? E, A and C. I didn't even see that. Moisture and oxygen. Soil to interface are usually more susceptible to corrosion than the rest of the structure because of moisture and oxygen. And that makes sense. I mean, if you're at the surface, the dirt's going to be damp and there's going to be oxygen because of the air around it. Carbonization can be confirmed by substantial increases in and loss of usually you're going to increase hardness and lose your ductility as a result of carbonization. And that's E. 20. Liquid metal embrittlement can occur if 300 series SS comes in contact with molten zinc. C. Molten zinc. Cracks that are typically straight, non-branching, and devoid of any associated plastic deformation are likely associated with which type of failure? Non-branching, no plastic deformation. That sounds like brittle fracture to me. B. At high temperatures, metal components can slowly and continuously deform under load below the yield strength. The time-dependent deformation of stressed components is known as, that sounds like creep. A. Creep. Permanent deformation occurring at relatively low stress levels as a result of localized overheating is called, that sounds like stress rupture. D. Blank usually occurs when a colder liquid surface at a warmer metal temperature. That's sounds like thermal shock. See, thermal shock. That's why you don't put a glass on a metal surface, so it'll cool too fast and break. Nickel-based alloys usually contain, I think it's over 30% nickel. A. Is a change in the microstructure of certain carbon steels and half moly steels after long-term operation in the 800 to 1100 range that may cause a loss in strength or creep resistance. Sounds like graphitization. Graphitization, the key is at 800 to 1100 range. What is usually found in aqueous environments or surfaces where the water is sometimes or always present, especially where stagnant or low flow conditions allow growth of microorganisms? That's MIC. Microbiological induced corrosions. Bacteria will grow when the water is stagnant. With chloride stress corrosion cracking, increasing temperature increases the susceptibility to cracking. And that's B, increasing. What is a form of cracking that results when certain multi-metals come in contact with specific alloy? Cracking can be sudden and brittle in nature. LME, I think it stands for liquid metal embrittlement, hence the molten metal. I wonder why my mouse is driving me crazy, but here, maybe I could just click back. No. Anyways, amine cracking has been reported down to ambient temperatures with some amines. Temperatures and stress levels, the likelihood and severity of cracking. Okay, increasing temperatures and stress levels increase the likelihood of cracking. A. Carbonate stress corrosion cracking usually occurs at welds or cold worked areas that have high residual stresses. C. Nitrane is usually confined to the surface of most components and will have a dull gray. appearance. In the most advanced stages, the material will exhibit very hard surface hardness. Carbon steel is susceptible to stress corrosion cracking when used in ammonia service. Okay. The grain size has an important influence on high temperature ductility and on the reheat cracking susceptibility. A large grain size results in less ductile heat affected zones. C. Large, less ductile. Equipment that is temper and brittle may be susceptible to brittle fracture during startup and shutdown. Amine stress corrosion cracking is a term applied to the cracking of steels under the combined actions and blank and aqueous alkylamine systems used to absorb H2S or CO2 and their mixtures from various gas and liquid hydrocarbon steams. Combined actions of, I want to say, tensile stress and corrosion. D. Blank is a similar to Hick, but is potentially more damaging form of cracking, which appears as arrays of cracks stacked on top of each other. The result is a thorough thickness crack that is perpendicular to the surface and driven by high levels of stress. So Hick. They go through this in the API 571 on the page. Weld heat affected zone graphitization is most frequently found in the heat affected zone adjacent to welds in a narrow band, corresponding to low temperature edge of the heat affected zone and multi-pass weld butt joints. These zones overlap each other, covering the entire cross section. Because of its appearance, the graphitization is called, I want to say, eyebrow. I'm not too sure. Eyebrow. At a given pressure, the H2S concentration in sour water decreases as temperature increases. Decrease of sour water. Okay, decrease. In order for PASCC to occur, the material must be sensitized. I went over this question earlier. Which API RP recommend programs to monitor small bore piping, flange faces, blistering, Hick, SOHIC, and HF alcohol units? That's 751, I believe. Low creep ductility is more severe in high tensile strength materials and welds. What is most likely found in hard weld and heat affected zones and high strength components? High strength components, I think that's SSC. Some type of stress corrosion cracking. I know if you have high strength materials, that tends to happen. But anyways, 44. At elevated temperature, the carboid phase in certain carbon steels are unstable and may decompose into, the decomposition is known as graphitization. That would be graphite nodules. There's a picture of it in the book. Hydrogen blisters may form a surface bulge on the ID, the OD, or within the wall thickness of a pipe or pressure vessel. Blistering occurs from hydrogen generated by corrosion and not hydrogen from the process stream. Since all fuels contain some amount of sulfur, sulfuric, and sulfurous acid, blank can occur if the metal temperature is below the temperature. That sounds like dew point corrosion. The best way to prevent 885 embrittlement is to use low, I don't know this one, ferrite alloys maybe, to avoid exposing the subcomponents to embrittlement range. Ferrite. Good guess. The amplitude and frequency of vibration as well as the fatigue resistance of the components are critical factors in vibration-induced fatigue. Cavitation is best prevented by avoiding conditions that allow the absolute pressure to fall below the vapor pressure of the liquid by changing the material properties. Hardness levels above, wow, are highly susceptible to hydrogen stress cracking. Time to failure decreases as the hardness decreases. This is just a guess, but 237 BHN. Yup. Take a break here.